What is good, 7th graders? We are constructing geometric figures, and to do that we're going to be using this toolbox, which is linked in your math book. Couple things to remember when you are doing these constructions. You're going to be doing rectangles and squares, so remember the angles on those rectangles and squares need to be 90 degrees. So you can use your pencil to do some constructions, but remember you need to have 90 degrees. So when you do this side, make sure that it's meeting the base at 90. A couple different ways that you can do that, but use a protractor to make sure that those sides are meeting at 90 degrees when you're doing rectangles or squares. When you are constructing triangles, you're going to want to use the compass. Sometimes you'll need to use the protractor as well if there's a specific angle that you need. Okay, so let's say first that we need to make a triangle with a 60-degree angle in it. Then we're going to use our protractor. We're going to put that protractor on the end of our base. We're going to mark 60 degrees on the protractor, move the protractor, connect the two, and that gives us a 60-degree angle down there. Okay, if the side lengths need to be specific measurements, then you use the ruler. Let's say that this one needs to be 7, then I would mark 7. And let's say that this side needs to be 5, so then I mark 5. Use my pencil, connect those, I have 7, and I have 5. And I met the conditions that I need for my triangle. Okay? There are two different kind of triangles we're going to be talking about. We have triangles that have an included angle and triangles that have a non-included angle. Okay, if we have an included angle, that's when the angle is in between the two side lengths, the two given side lengths. A non-included angle would be an angle like 25 degrees over here, kind of just estimating that. That is not between the two side lengths. Okay, so the two side lengths are away from the angle. That is not included. When the angle's in between, that's included. Okay, you're going to be constructing a couple different types of triangles, and that's one vocab word that you're going to need to know. Okay, we're going to construct a triangle with side lengths of 3, 4, and 5. Okay, so it's easiest a lot of times if we put the long side on the bottom. So let's do that first. So we'll go all the way out to 5. Okay, then our other two sides we're going to use the compass to do. So we need a side with a length of 3. So I'll put the end of the compass on 0, stretch it out to 3, and then I just make a mark with my compass. Then I'm going to take that compass and move it to the other end of my base, or the bottom side, and it needs to be 4, so I stretch it out a length of 4. Notice I don't go to the number 4, because that's only a length of 1. I need a length of 4, which brings me 1, 2, 3, 4, all the way down to 1. Make a mark. Now, where those two marks intersect makes my triangle. So I go to the end of my base, and draw a line to where those two arcs intersect. Same thing over here. And now I have my triangle. I have some marks that go through my triangle. That's okay. We can still see the triangle. And if you want to make those marks a different color so that the triangle stands out more, that's great. But I can now label those 5, 4, and 3, and I have my triangle. Okay? If we needed to construct an equilateral triangle, we start out with our bottom side again. Let's say it's a length of, let's go 6. Stretch it out that far. Take our compass, We don't need the ruler anymore because equilateral, all three sides are the same. So I'll stretch it out the length of the whole base and make an arc. Move the compass to the other side. Don't change the length on the compass. If you do change the length of the compass, then stretch it out to the full length of the base again. Make another mark. Get rid of my compass. Now where these two arcs intersect is going to make my triangle. And I should have a nice equilateral. Okay, that was 6. So all three of those are 6. Okay, we're going to look at a triangle that has an included angle of 50 degrees and side lengths of 4 and 5. Okay, so again, we'll start with the longest side on the bottom, which in this case is 5. So we draw a line out to 5. The next thing we need to do is make our 50-degree angle. Now on our protractor we have two options, a 50 on the right or a 50 on the left. If I do the 50 on the left, that's going to make an obtuse angle. But a 50-degree angle is not obtuse. So I need to use the 50 on the right side. I'll mark it, get rid of my compass and my ruler, draw a line going through that mark, and I usually go past it to make sure it's long enough. So I have a 50-degree angle down here. The bottom side is 5, and then the top side over here needs to be 4. So I can move my ruler up to 4. I'll mark it at 4 right there, get rid of my ruler, draw a line from the end point to that mark, and now I have my triangle. This side over here is 4, included angle of 50. It's in between the two sides. That's what included means, between the two sides. All the conditions are met, so I have my triangle. Okay? I'm going to change that slightly. And let's change it from included. Let's go non-included now. Okay, not included. So this angle is going to move from between to away from those two sides. Okay? So let's start again with our bottom side. We'll make it a length of 5. And we need a non-included angle of 50. So we'll move our protractor over here. Again, we're going to mark 50 degrees. Get rid of our protractor. Draw the angle of 50. So that's 50 down there. We have 5 on the bottom. Now, so far it looks the same, but I can't have the length of 4 be over here because that's included. For it to be non-included, which is what we're doing now, non-included, the 4 has to be on this side. So I'm going to take my compass, make it a length of 4, get rid of my ruler. It's still at a length of 4. I move it to the other side and now make an arc. Get rid of my compass. You'll notice it intersects the side in 2 places. There's a point of intersection here and a point of intersection there. That means I can actually make 2 triangles with these conditions. A side length of 4 and 5 and a non-included angle of 50. I can draw a line from the end point to this point of intersection. That makes a triangle with sides 4 and 5 and a non-included angle of 50. I can also draw a line from the end point to this point of intersection, which gives me another bigger triangle with side lengths of 4 and 5, a non-included angle of 50. So I have a small one and I have a big one. There's actually 2 triangles that meet these conditions. There's only one for the included angle. There's going to be questions where I ask you, is it possible to make 0 triangles, 1 triangle, or 2 triangles with a non-included angle? So you're going to need to set it up like this using the compass and the protractor and draw the arc and see, does it intersect twice, does it intersect once, or doesn't it intersect at all? Okay, for example, if I said this side was 3 instead of 4, then it would not actually intersect that other side at all. It'd be too short. Okay, so if I get my compass back and my ruler, if I stretch that out to 3, my ruler's not coming back, so let's just say this is 3, because it's pretty close. It's not long enough, it doesn't hit that other side, so that would make 0 triangles. Sometimes you'll draw that arc and it will hit just perfectly and only intersect that side once, and that's going to make 1 triangle. Or, like it did this time, it goes through, past, intersects twice, and makes 2 triangles. Okay. Last thing I want to talk about is the triangle theorem, which is you can look at 3 side lengths and determine if it makes a triangle just by looking at those side lengths. So let's say we have 4, 6, and 8. What the theorem says is you pick any 2 side lengths and add them together. It needs to be longer than the third side in order to make a triangle. Okay? So if I pick 4 and 6, add those together, that makes 10. 10 is longer than 8, so it works. Okay? If I pick 6 and 8, add those together, that's 14. 14 is bigger than 4, it's longer than 4, so it makes a triangle. Okay, if we pick 4 and 8, add those together, we get 12. 12 is longer than 6, so yes, it will make a triangle. All 3 combinations added up to longer side than the third one. So then it would make a triangle. Or all 3 combinations, when we add them up, those 2 numbers added together is a bigger number than the third side, so then it will make a triangle. Let's try another one. How about we do 5, 8, and 2. Okay, let's go through the combinations. If I do 5 and 8, that adds to 13, which is bigger than 2. It makes a triangle. If I do 8 and 2, that's 10, which is bigger than 5, the one we haven't used yet. So that's good. It's looking like it's going to make a triangle. But if I do 5 and 2, that adds up to 7. 7 is not bigger than 8, the number we haven't used yet. So it's actually not going to make a triangle because those 2 sides together won't meet to make a triangle. And let me show you how that works, what I'm talking about. Okay, if we have 5, 8, and 2, first thing I'll do is put the longest side on the bottom, which is 8. Then I'm going to use my compass to try and draw the triangle. Pick another side, let's do 5. So I stretch it out to 5, make a mark. And then I'm going to move my compass to the other side. And this time we will stretch it out to 2, which brings us down to 6. Make a mark. Get rid of my compass and ruler. So what happens is if I draw the sides, those sides never actually meet. They're not long enough to meet and make a triangle. So that's why the theorem works. Because if I pick 2, add them together, and it's not longer than the third, then they're not going to meet and it's not going to make a triangle. All right, let's try some examples.